Hi, we're going to take a look at lesson 5 of triangles and congruence. We're going to explain how to use SSS and SAS to show true triangles are congruent. We're going to use congruent triangles to solve problems and prove triangles congruent by SSS and SAS. So in the past, we've learned that for triangles to be congruent, you have to show that all 6 corresponding sides and angles are congruent. That means all 3 corresponding sides, all 3 corresponding angles must be congruent and represented in your proof. This time, we're going to take a look at some shortcuts. So instead of having to show all 6 parts are congruent, we only have to actually now show 3. So today we're going to introduce 2 out of the few ways to prove triangles congruent. We're going to talk about SSS first, and SSS stands for side, side, side. It's when all 3 sides of one triangle are congruent to the 3 sides of another triangle. And if we take a look at the markings, we see that AB is corresponding to DE, BC corresponds to EF, and AC corresponds to DF. So if we have all 3 corresponding sides congruent, then we can go ahead and say that triangle ABC is congruent to triangle DEF. The next method is called SAS, which stands for side, angle, side. It's when 2 sides and the keyword being included angle of one triangle is congruent to 2 sides and the included angle of another triangle. Meaning that if I'm looking at these markings, notice that the 2 side congruent markings have to be adjacent to the congruent angle marking. They have to be touching, okay? That's what included means. So one of the things that we're going to take a look at is identifying the corresponding parts for side, angle, side. So in our case, we have AB is corresponding to DE, angle B corresponds to angle E, that's our angle, and then BC corresponds to EF. Because all 3 corresponding parts are congruent, then the triangles are congruent. We're going to take a little sidebar, and we're going to take a look at how do you read congruent markings. There are 2 things to keep in mind. So first thing that we're going to do is we're actually going to label our markings as sides or angles. So this marking is for side, so I'm going to put a little S there. The E is for an angle, and then EF is for a side marking. So we have to figure out where do we start. So you start with the marking that is kind of far away from all the others. So it's like one of the ones on the edge, not one smack dab in the middle. So either one of the S's would be the ones towards the edge, because notice how those are closest to the parts that don't have any markings on it. So I'm going to go ahead and start with this one. We have to read it in clockwise or counterclockwise order, and we could skip at most one side or angle. So if I go clockwise, that means I'm going to go to A next and then the S. And notice that I go directly to an angle marking, and then I have the other angle marking right away. So I didn't skip any side or angle when I read those in order. So it would be side, angle, side. Now let's say we went counterclockwise. If I go counterclockwise, that means I'm going to be going this direction. But notice that there is no marking on angle D, there is no marking on side DF, and there's no marking at angle F. That's 3 parts of the triangle that we had to skip to get to S. I can't skip 3, I can only skip at most 1. So if you think back to side, 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 I skipped all of the angles. That's 1 part before you get to the next marking. So you're allowed to skip 1 part in between each marking, but no more than 1. So side, 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 we skipped 1 angle in between each congruent marking. So let's go ahead and take a look at our examples. We're going to practice identifying if the triangles are congruent or not, and by which method. So in the example number 1, I have a side marking here, I have another side marking down here, and I have angle A or angle Y congruent. So I'm going to put a little A. I'm going to have to start with one of the sides because there's no congruent marking to the left of the triangle. So I'm going to go ahead and start with the one at the top. I'm going to go clockwise because A is directly next to the congruent marking for the side. So I would read this as side, angle, side. And side, angle, side is a way to prove triangles congruent. And notice that this triangle is also side, angle, side when we read them in order. I cannot go the opposite direction. I can't go counterclockwise because I'm skipping an angle, a side, and an angle. So by following the rule about not skipping more than one, or at most one side or angle before you get to the next marking forces you to go either clockwise or counterclockwise. Only one of those directions will satisfy how you read the markings correctly. Because we do have triangles congruent by side, angle, side, then we have to write a congruent statement for part B. So we can state that triangle TQY is congruent to triangle T corresponds with P, Q corresponds with C, and Y corresponds with K. In example 2, notice that there's only 2 congruent markings labeled for you. Then you might want to think about where a third congruent marking can come from directly from the diagram. And then go ahead and try example number 2. Hopefully you got side, 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 because triangle ADC is congruent to triangle ABC. Reflexive property is what gave us this third congruent marking, because AC is congruent to itself. It's the same segment in both triangles, why it has to be congruent to itself. Example number 3. So this one's interesting because you have the triangle overlapping. If it's easier for you, feel free to separate and relabel the drawings. You can see in the picture and when we redrew it that MK and MK are labeled twice in both drawings. So then this segment has to be congruent to itself because it's the exact same segment in both triangles. It's overlapping on top of itself. So by reflexive property, MK is congruent to KM. Now I put my markings on. I have a side, I have an angle, and I have another side. So I can read that as side, angle, side. So then triangle JMK is congruent to triangle LKM. Example number 4, let's go ahead and label our markings. I have an S here and an S here and an A here. And I'm going to start with this S right over here. I'm going to read it clockwise because I'm skipping only one angle to get to the next marking. If I go the opposite direction, I'm skipping an angle and a side. So I can't go that way. So I have side, side, angle. Well, unfortunately, side, side, angle is not a way to prove triangles congruent because so far we only know side, 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 and side, angle, side. In a different lesson, we're going to investigate a few other options, but side, side, angle doesn't prove triangles congruent. A way to remember that is if you spell it backwards, think about what that spells, and that will help you remember that anytime you come across those letters in the same order, don't write it down as being SSA, just write not congruent.
Hi, we're going to take a look at lesson 6, which is about proving triangles congruent using ASA, AAS, and HL. We're going to explain how the criteria for ASA and AAS are used to show triangles congruent. I'm also going to be adding in HL and showing how to solve problems with it and proving triangles are congruent using ASA, AAS, and HL. So we're going to start with ASA, and it stands for angle, side, angle, which means 2 angles and the included side of one of the triangles are congruent to 2 angles and the included side of another triangle. Then the triangles are congruent. So we have angle A corresponds to angle D, AB is corresponding to DE, and angle B is corresponding to angle E. Because the 3 corresponding sides are congruent to the 3 corresponding sides of the second triangle, then the 2 triangles are congruent. I do want to take a little time to talk about how to read the angle markings for these. So I'm going to label the markings. This is for an angle, this is for a side, this is for an angle. And we know that if I start at one of the angles, notice that those are the ones on the edges. So I'm going to start with this one. Then if I try to read it clockwise, I'm skipping side BC, angle C, and angle AC, so I can't read the markings that direction. I have to go counterclockwise. So counterclockwise, I go directly to S and then directly to A. I'm not skipping any side or angle before I get to the next marking. So when it's talking about included side or included angle like in SAS, you are not skipping any side or angle before you get to the next marking. So it's 3 directly in a row. The next one would be angle side. And this one's talking about 2 angles and the non-included side. So we have angle A corresponds to angle D, angle B corresponds to angle E, and BC corresponds to side EF. So I'm going to label, we have an angle, and we have a side. And when we try to read our markings, I can start at like this angle's kind of away from the other one. So if I start here, if I go counterclockwise, I'm skipping side AC and I'm skipping angle C. So it forces me to go clockwise direction, starting with this A. So then I'm skipping side AB, but then I hit the congruent marking at angle B and at side BC. So that forces me to read my markings clockwise, so angle, angle, side. It's the same thing as if I start with the side, reading it side, angle, angle. The last one, the last shortcut we're going to take a look at to prove triangles congruent is called HL, stand for hypotenuse leg. There are 3 criteria for this. The first criteria is that you have to have a right triangle. Okay, so HL only exists if you have a right triangle. Second, you have to have a hypotenuse congruent in one triangle to the hypotenuse congruent in the other triangle. And then the third piece would be the legs. So you have 2 legs in a right triangle. You only need 1 pair of corresponding congruent legs to use HL theorem. So HL, and then knowing that it has to be a right triangle. So then in our case, BC and EF are corresponding, and AB and DE are corresponding. Because both the hypotenuse and 1 pair of legs are corresponding and congruent in both triangles, then we can say that the 2 triangles are congruent. I also want to refresh your memory that the hypotenuse is the side opposite the right angle. And again, the leg is adjacent to the right angle, meaning that it's one of the other 2 sides of the right triangle. Now we're going to go ahead and take a look at a bunch of examples. So in our first example, we're trying to determine if the triangles are congruent by ASA, AAS, or HL. So we have an angle down here. That means we have to have a side. Now is a good time to talk about how angle, angle, angle is not a way to prove triangles congruent. So SSA and AAA does not prove triangles congruent. Okay, these are the only 2 methods that do not work. So that means I have to know a side. And you can see that SU is the same segment between the 2 triangles. So we're going to use reflexive property to show that it's congruent to itself. So if I read my markings, it's just ASA. And then I need to write a congruent statement. So triangle SRU is congruent to triangle STU. In example A, or example 2, part A, we already know that you have a right triangle. So that should be a trigger right now that maybe I might be using HL theorem. If you have a right triangle, you want to check for that. I do have a pair of legs congruent right here, so I'm going to call that legs, right angle, and then SQ is congruent to itself by reflexive property, and that happens to be the hypotenuse. So in fact, we do have HL theorem, so triangle SPQ is congruent to triangle QRS. Go ahead and try example number 3. Do you think it's congruent by ASA, AAS, HL, or not at all? Now, KM is congruent to itself by reflexive property, so that gives us another side. So when I label my markings, I have S, and S, and an A. Well, remember SSA is not a way to prove triangles congruent, so I don't write SSA in the line, I actually write not congruent. Example number 4, go ahead and write down if you think the triangles are congruent. If so, then how? By reflexive property, we see that KM is congruent to MK. So that gives us another side. I'm going to label my angles in my side. So I have angle, angle, side, and showing how the triangles are congruent. So corresponding parts would be triangle JKM congruent to triangle LMK.